This is a video about the properties of waves. You've recently learned about two different types of waves, a longitudinal wave and a transverse wave. So we're going to talk about some of the properties of those waves. First is a crest, and a crest is on a transverse wave is here at the top. So it's really easy to notice the crest of a transverse wave. So we're going to label this crest. So it's referring to this top portion of the wave. The trough is the low point on a wave. And so down here on this bottom picture, the area that's going down here, this is considered the trough. The rest position is the position before the wave has been moved. So it's right here in the very center of the crest and the trough, and you can see it by the dotted line on the diagram. Another property of a wave is its amplitude. And the amplitude is referring to how far the medium in the wave moves. So remember that a wave has to have a medium to move through. So we're talking about how far the medium moves. In a transverse wave, the wave that goes up and down, like moving a rope up and down, it is the height from the resting point to the crest. So if you take a look at this diagram here, this is showing you this black line is the resting position, and the amplitude is from the resting position to the crest, or you could measure it from the resting position to the trough, which it should be the exact same measurement. On a longitudinal wave, the amplitude measures how compressed or rarefied the medium becomes. So we're looking at how compressed the material that the wave is moving through becomes, or how pulled apart it becomes in the longitudinal wave. And if you remember back to longitudinal waves, you should have already learned about the compression part of a longitudinal wave, which is shown right here. So in like a spring toy, it would be the part that's pushed together, or the rarefaction, that's the area that is pulled apart. The next property of a wave we're going to discuss is the wavelength. And that makes a lot of sense, the word length, because we are just measuring the distance between two corresponding parts of a wave. In a transverse wave, the wavelength is the distance from crest to crest or from trough to trough. So if we look at the diagram here, let's look at the yellow rope line. So here is a crest and here is a crest. So we would consider this length one wavelength. Or again, with the yellow rope, we could do trough to trough, and that would be one wavelength. And if we were to measure crest to crest or trough to trough on the yellow rope, it should be the same length, and that would be the wavelength. If you notice, they have a blue rope going through here too, and you can see that its wavelength would be different. And then if we look at the green rope, do you see how the crests are closer together than the yellow? That means that the wavelength is shorter than the wavelength is on the yellow. So we could do trough to trough as well. So it would have a shorter wavelength than the yellow rope has. Same thing on a longitudinal wave. The wavelength is the distance between compressions. So if we look at this diagram, here is a compression, and I usually say go from the middle of the compression to the middle of the compression. So this would be considered one wavelength. And so if the wavelength was shorter, that means that the compressions would be closer together. Here's another example of a longer wavelength in a transverse wave. So you can see a longer wavelength means that the waves are spread out more. A shorter wavelength means that the waves are closer together. Which leads to the last property we're going to discuss in this video, and that is frequency. And if you think about what the word frequent means, it means how often something happens. So frequency of a wave is the number of waves that pass a given point at a certain amount of time. So if I go back and look at this picture here, you will see that this wave that has a shorter wavelength is happening more often, so it would have a greater frequency. So a shorter wavelength has a greater frequency than a longer wavelength. Frequency is measured in the unit of hertz, and we use the unit capital H, little z, and that will become important in the next video you will watch about calculating speed, frequency, and wavelengths with waves. You'll need to know that unit. Thank you for watching, and please watch again if you need to review any of this information.